So this is lesson 2 of module 1, so we're going to do the same objective as yesterday. So reason abstractly using place value understanding to relate adjacent base 10 units from millions to thousands. So again, we're going from the biggest number we have on our place value chart all the way to the smallest, which is thousands, okay? But the only difference with this objective is we're reasoning abstractly, meaning that we're taking the place value chart out. So we're not working on the place value chart, we're not physically moving the numbers, but we're going to move the decimal today using our knowledge from yesterday, okay? So we're going to get started. We're going to kind of skip our fluency practice today just because I want you guys to have enough time to get questions answered and stuff.
We get place value
You just have to like move the decimal instead of like using the entire thing.
Kind of, but let's get through the lesson first, and then we can ask that clarifying question, okay? All right, cool. We're gonna warm up with this. So a school district ordered 247 boxes of pencils. You read the rest to yourself. Ready, go. Hello. Sorry. There you go. I usually put MS period, but either is fine. So, okay. Gotcha. Okay. Thanks. Okay, did you read it?
Yeah.
Okay. So a school district ordered 247 boxes of pencils. Each box contains how many pencils?
100.
100. If the pencils are to be shared evenly amongst 10 classrooms, how many pencils will each class receive? So this is going to be kind of like a two-step problem, okay? So total they ordered 247 boxes, okay? Each of those boxes, okay, so just one of these, one box, equals how many pencils? 100, okay? Right now I want you to find how many total pencils there were in the 247 boxes. So how are you going to solve that? Multiplication, okay? Multiplication. Try it out. Yes. You're not going to use that. Well, actually, yeah. You can. That's a good point, Johnny. So Johnny is going to use the place value chart because it's similar to our homework, right? 247 times 100. So it moves on the place value chart. Which direction?
Forward.
Left. Don't say forward. Say left or right, okay? Because there's not really like a front or back. So just say left or right. So it's going to move to the left. How many spots? 2. So if you want to draw a place value chart and do it that way, go for it. If you want to do it the good old-fashioned way, you can do that as well. Okay. It's in. Well, for the final answer? Did we get there yet? We're just finding how many total pencils there are. Total pencils. Yes, that's what Johnny is doing. I don't know. That you can figure out on your own. Okay, think about what place values you're going to use. You're going to figure that out. Think about what place value you're starting with, and then go from there. Okay. If you need to add another one, you can. Like when you're going through it.
Never mind.
Yes. Although be careful here because you want to make sure that you're doing like zero times this, times this, right? But then there's also, if we're doing it this way, that's the way you're going to do it. But think about how we multiply over by 10, right? And you can get it like that. Okay? But think about like what I was just telling Lily. So we multiply like 12 times 10. How do we do that? You can, or remember we can do this number and right? So it saves you a little bit more time. Okay? Alright, good. If you did the place value chart, are we working today, Claire? I don't know. I have to see. Alright, cool. Okay, so here's ones, tens, hundreds, thousands, 10,000s, 100,000. Okay. What number am I starting with? Go. 247. 247. We're moving which direction? Because we're multiplying.
Right.
Which direction? We're multiplying. It's getting bigger. Left. Okay, follow me with your eyes really, really quick. Okay? So, if we're multiplying, our number is getting bigger, right? If we're going to the right, our number gets smaller. Notice how it goes 1, 10, right? Is 10 or 1 bigger? 10, right? Then 100, right? So use that to help you. So since we're multiplying, it's going to get bigger, which means we need to move to the left, okay? How many zeros are in 100? 2, right? So it's going to move to the left how many times, friends? 2 times, okay? So 1, 2, give me 2, 47, cross that up, okay? And then 0, 10, 0, 1. So you should have gotten 24,700 for total number of pencils, like single pencils. We're not quite done yet though, okay? Yes, Donnie?
1 second. Oh no, never mind.
You ready? Okay. Okay.
I just got
I'm gonna ditch this really quick, okay? Whoop. So, total number of pencils now, we have 24,700, amen? Anyone confused on how I got that? Charlie?
What if you got a decimal?
Nope. Because we're just working with a whole number. So if it didn't start with a decimal, odds are we don't need a decimal unless we're moving that way. But we are moving away from the decimal, so we don't need it.
But it was between the decimal.
It started in the ones place. Started in the ones place and it moved to the left. So it started here, right? The last digit, the 7, was in the ones place and it moved to the left. So here's the decimal. It moved away from the decimal, so we don't need a decimal. We only need a decimal if there's a fraction of a number, but it's a whole number. 24,700 is a whole number. But if I have 24.70, right? The whole number is what, Charlie? 24, right? The fraction of the number is 0.7, okay? That will make more sense later. Right now, we just need to know that we moved away from the decimal, so we don't need a decimal. But we can put one in, but it would just be right here. And then it would just go on, but we don't need that, right? Because this right here is the whole number, okay? So don't think about it too much. That's not the part I want you to focus on, okay? Don't worry about the decimal. The part I want you to notice is that we moved up on the place value chart, meaning it got higher. Okay? It's just like our homework yesterday. We moved to the left because we multiplied because our number got bigger. Okay? Just like our homework yesterday. That's all we did. Okay?
But that's what I did and I got a decimal.
Where did you put the decimal? That means you moved to the right. You moved this way instead of this way. Okay? We multiplied, so it got bigger, which means it moved to the left. Okay? Whenever you see multiplication, this symbol, okay, we're moving to the left. If you see this symbol, division, we're moving to the right. Okay? You did not, because left is gonna be this way. This way. So I don't know how you got a decimal then if you move to the left. You put it in a funky spot then, which is okay. Okay. But right now I want you to erase what you have and put 24,700. Okay. So erase what you have. Put this. Okay. Right now. Go ahead. Do it. All right. Moving on. So, how many classrooms are in the school that are sharing these pencils? Go. 10. Okay. So then we go back. Whoops. We go back to our place value chart. Okay. Or you can do standard algorithm and divide, but this might be a little faster. Okay. Yeah. No, that's fine. So ones, tens, hundreds, thousands, 10,000s, 100,000. Okay. I don't need to put the spot with the decimal. I don't need that because we're just starting with a whole number. If I needed to add that later, I can, but we don't need that part because we're just starting with a big whole number, okay? So 0, 0, 7, 4, 2. Does everybody understand why I put those digits where they are? Okay, because in this number right here, 24,700, I have 0 ones, 0 tens, 700s, 4,000s, 2 10,000s. Okay, so I just placed it right in the place value chart. You start with the ones place and go that way, right? So now we're going to divide the number of pencils amongst 10 classrooms. Okay? So in other words, we're moving this number which direction, left or right?
Right.
Right. Awesome. Thank you. We're moving to the right. How many times?
Once.
Once. Henry, why once?
Because in 10 there's only 1 0, and you'll move back like or forward or move to the left or to the right, however many zeros it has.
Good. Yes. So 10 only has 1 0. So that means we're just moving one place value to the right. Okay? So everything's just going to jump over one spot to the right. Okay? Because it's getting smaller. So we need to move to the smaller part of the place value chart. So I'm going to do that in another color. So I'm going to start with the furthest one. Okay? So that is going to move over to the tens place. Okay? So technically we can put the decimal there. Okay? But it is just a 0, so it doesn't totally matter. Okay? So this is the decimal spot right here. So that 0 moved over here. That 0 moves here to the ones. The 7 moves from the hundreds to the tens. The 4 moves from the thousands to the hundreds. And the 2 moves from the 10,000s to the thousands. Okay? So we divided 24,700 by 10, and we got 2,470.
So,
Charlie.
Wouldn't you move it over 2 times?
Why 2 times?
Because there's 2 zeros.
In that number, yeah. But we focus on
The 10.
the multiple of 10. So 10 has how many zeros?
1. So
One.
we move
Just
it over 1.
And do you see why we moved to the right this time?
Because
And how-
we're divided.
Divided. Beautiful. Yes. You got it. You got it. Henry?
I did the standard algorithm, and this one's super easy. You're using the standard algorithm.
Yes. Yeah. It is. But since we learned this yesterday, I wanted to kind of like focus on this a little bit more. But yeah, it is easy because you also too. There's a quick trick, but remember we need to know the why, right? But the quick trick is that you can just cancel out the zeros, right, to get 2,470. But
That's what I do.
you need to know the why. You need to know the why, if that makes sense. Yes,
Why'd you
Charlie.
put it, after the decimal behind it?
One more time, sorry.
Why'd you put it behind the decimal?
Because the next place value over is the tenths place. Look up there. Where's the decimal? Do you see it? What's the next place value to the right? Tenths, right? So it jumped. This is not a place value. This is just the decimal. So it's got to move to the next place value over, which is the tenths place. 2,470, period. We can forget about that guy. That doesn't matter. If this was a 7, then we would need to include it. But since it's just a 0, 0 is nothing, right? 0 equals nothing. So we can just forget about it. Okay? So our final answer is 2,470. All right. Cool. So that's what you did for homework last night, basically. But this is just putting it in word problem format. Okay? So go ahead and erase all that. We're going to move on. I know we took a long time on that. Okay? So right now, let's see. So right now, you can just have your notebook as the focus, okay? Donna, I need you to put that book away or I'll take it. No! I need you to see what just happened. I told you to erase. See what happened? Okay. So I'm trying to focus a little bit more just on what's going on. your focus right now, so you can put your whiteboard underneath your notebook if that's going to be more helpful, or you can put it in your desk, whatever you got, okay? And right now you're just going to we're going to discuss a little bit of what we see on these next problems. So you don't even really need to write much right now, but you can just kind of look up here. So right here, it says study both problems. What is the same and what is different? You don't need to raise your hand right now. Okay, you're just going to think about it to yourself. So everybody right now is looking at the board, looking at those two problems. Think about what is the same and what is different. Don't say anything yet. You're just going to look at those. So you're not saying anything yet. You're just looking. All right, class. What operation is this right here?
Multiplication.
Multiplication. Good. So you're going to multiply on that one. What operation is right here?
Division.
Division. Okay. Good. Are there any other differences?
Yes.
Henry, what? Emma?
Division will move to the right and multiplication will move to the left.
Well, good. So that's a difference in how to solve it, but we're just looking just at the problem. Not really how to solve it yet, but just the problem. Are there any other differences between the problems? Not how to solve it, but just looking at the problem. Charlie?
When you multiply that number, and then when you divide that number with other numbers.
I see what you mean. Yeah. So when you multiply, the number just gets bigger. But when you're dividing, it gets split up into different, yeah, I see that. But that's still just how to solve it. So guys, the answer is no. There's not any other differences. It's multiply, divide, right? But then my next thing, right, so then Emma, talking about place value, what direction would this number move on the place value chart? Left. Good. It would move left. Okay? Charlie, with division, what direction do we move? Right. Good. Okay? Whoop, that's how we solve it, right? And then Charlie had a great point. When we divide, it gets split up into all these different groups or whatnot. But when we multiply, it just gets bigger, right? The number just gets bigger. Good. Okay. Good so far? Okay. Awesome. Same thing, right? One's multiplication, one's division. We're multiplying by 10, dividing by 10. The top one would move to the left, the bottom one would move to the right. Good so far?
Yeah.
Charlie?
I have a question. If you did the same answer on both of them with their division, you'd still get the right answer with the division, right?
Wait, can you say that one more time?
If you did both of those same numbers and then multiplication with division, would you still get the same number with both of them?
You should get different answers for these. Right? Because they're different operations. When we multiply the number, it gets what? Bigger, right? And then when we divide, it gets smaller. Okay? So, I think I know what you're saying. The digits would be the same. Right? Like this 6 wouldn't suddenly change to a 12 or whatever, you know? Like, this wouldn't change to a 3. It would the digits are the same. Digits are the part that make up a number, right? So 4 is a digit, 3 is a digit, blah, blah, blah. But, like, so the digits are the same, but the number is going to get bigger or smaller. So the answer is different. It is different. But yeah. All right, so then here, okay, now think about it. What do we notice that is the same, different? Think about it, don't say it. Think about it, don't say it. All right, Melina, what are some differences between these two problems?
One of them is division and time.
Good. Multiplication, right? One of them is multiplication. One of them is division. Good. Okay. What do you notice? Sorry to pick on you, Melina. What do you notice about these problems versus the last one? Different numbers. There's a decimal. Good. There's one more thing too. Those are definitely right. Emma, what's the other thing?
The last two problems were times 10 and this problem is times 200.
Good. Yeah, the last ones were times or divide by 10. These ones are times or divide by 100, right? So they would move, this one would move to the left, right? What direction would this one move?
Right.
Right. I don't know why I can't draw an arrow today. Good. But how many times? 2. Okay, there's 2 zeros and 100. So they're both going to move their different directions 2 times. 2 times, okay? All right, we're getting there. So then here, same deal, right? But how many times are they going to move? 3, right? There's 3 zeros. So this is kind of review from yesterday. So now, here's what I want to, we are technically at the problem set, but I'm going to use the problem set to teach you more, okay? So you do still need to have your notebook out, but you can put your whiteboard totally away. And then, gardening crew, can I have you pass out the problem set? And just put the extras in the Wednesday part of it, okay?
We've been sitting for a while, so I feel sweaty.
Stand up, wiggle it out.
Whoa, this is giant doggy.
No, keep your notebooks out, but my
Look at my shirt. It's so dressy.
Put your name on the problem set. Alright, do me a favor, stand up. We're going to stretch it out a little bit. If you don't want to, that's fine. But
Stretching good.
this is a brain break. Okay? So you can stretch your arms to the sides,
I did this to
stretch them up, stretch down, fix your neck. My neck's killing me.
like that.
Okay.
This is really good. She caught my neck. Oh. Good.
Take a couple more seconds and then we're going to get going again.
I did it. Now you gotta. I need my shoulders. I need a massage. My handy.
Alright, I want you ready to go again in 5, 4, 3, 2, 1, 0. Alright. Yes, sir. It's the 18th, August 18th. Can you just write 8/18? Just so we can keep moving, okay? Alright. So, this looks a little different than yesterday, right? Yeah, alright, I'll see you guys later, okay. No, looks a little different than yesterday, yes? Yes, thank you. Okay, it does, a little bit. There are no place value charts, right? So like I said, we're taking those out today, and I'm about to confuse you a little bit, fair warning, okay? But do not let yourself get too confused, all right? We're gonna stretch it a little bit. So, I'm gonna take this problem, I'm gonna write it, let's see, on like a blank one. Okay, open one. Oh, that's not what I meant. Oh, no.
It's sort of blank.
There you go. There we go. Okay. Luke, can you read me 1A or whatever it is?
Okay, 54,000 times 10 equals a line.
Equals a line. Good. 54,000 times 10 equals blank. Okay. So, I don't want you to write anything yet. I'll tell you what to write. Olivia?
Oh, no, it's times. No, first one's times.
1A?
The second one is divided.
Okay, that's okay. That's okay. So,
he's doing
54,000. 54,000 times 10. I don't want you writing anything yet. I want you to just look up here. Okay? So this number right here, 54,000 is what we're focusing on. Okay? Check it out. How many 10,000s do I have in this number? 5. Okay? Just say it once, just say it 5. Okay? How many thousands do I have in this number? 4. Okay? Oh. Oh. How many hundreds do I have in this number?
0.
How many tens?
0.
How many ones?
0.
Good. Pause. 0 ones. Look up at that place value chart. It goes ones, and then what's the next thing?
Decimal.
Decimal. Not tenths yet. In between ones and tenths, there's a decimal. Amen?
Amen.
Y'all see that?
Yep.
Okay. So in between ones and tenths, there's a decimal. So ones, decimal, then what's next?
1.
Oops, then what's next? Going to the right. Tenths. Okay? How many tenths do I have? Trick question. 0. Okay? So, check it out. This is still 54,000. Okay? This is still 54,000 right here. We have 0 tenths. 0 tenths. It's just like any other place value. Just like if we had 0 hundred-thousandths, right? That's the next one from 10,000. I could technically put a 0 there. Do we normally put a 0 there though? No, we don't. Okay? We don't normally put a 0 there. Because it's not needed, right? Like I was telling Charlie earlier, 0 means nothing. So we don't need to put a 0 there. Just like we don't need to put a decimal and a 0 here. Okay? However, for today's lesson, okay, this is what we're doing a little differently, and I need you to watch closely, okay? Because you're going to be super confused and no. So, 54,000 times 10 means it's going to move which direction on the place value chart? Point. Point. Don't say it. Point. What direction does it move if we're multiplying? It, like looking at me, is it left or right? Point. Left or right? Good. Left. Okay, I'm not saying everybody do it. Which direction does it go?
Left.
It goes left. We're multiplying so it's getting bigger. Now, check it out. When it shifts left, okay, I need you to watch this. When it shifts left on a place value chart, we move away from the decimal, right? Which means that the decimal moves to the right. Okay? So, it shifted to the left, which means the decimal moved to the right. So we're playing more of an opposites game today, okay? So when I moved it to the left, the decimal moved to the right, okay? Did the decimal actually move?
No.
No. The number moved away from the decimal, okay? Which means that another 0 was now in the ones place. Everything shifted up, okay? So everything shifted up, which means now there's another 0 in the ones place. So 1, 2, 3, comma. Now I have 540,000, okay, instead of 54,000. All right, so simply my answer is 540,000, okay, because it moved. We had 5 10,000s, right? 5 10,000s, 4 thousands, right? And then when we multiplied everything, you need to watch this. Waiting. Okay. Everything shifted up. Just one spot. So the 5 is now here. The 4 is now here. 0 here, 0 here, 0 here, 0 here. So now I have 4 zeros instead of 3. Okay? Questions on what I just did?
No.
Charlie.
When you moved it, you did it like put it in the chart, just move all the numbers once.
It just moves over once. But then when we move over, then that 0 that was in the 10th place when we started moved over to the ones. Okay? So then to help with that, I'm going to show you like a different problem. So if I had 321.44, okay, and I'm multiplying that times 10, check it out. 321.44. I'm multiplying that by 10. It's going to move to the left how many times? Once. Okay? So everything's going to shift to the left away from the decimal once, right? So, bloop. So now that 4 that was in the tenths place when we started, right? This 4 right here was in the tenths place when we started. Since everything moved that way once, it's now in the ones place, right? Because it just moved up. And then that 4 right here that was in the hundredths place is now in the tenths place. Okay? Charlie.
How did it move up exactly? It just.
One more time, sorry.
How did it move up?
Multiply. Remember when we multiply, everything moves to the left. Okay? Everything. Even if it's behind the decimal. Everything moves. Okay? What?
It moved right though.
It did not. The decimal moved right. The numbers moved left. Okay? The numbers all shifted up on the place value chart. Remember I was standing over there and it said, now it's here, right? Everything moved up on the place value chart. It moved to the left. The decimal moved to the right. But it didn't actually move. It stayed where it was at and everything moved around it. Okay? I will come help you in a little bit. I'll show you on a place value chart, okay? But right now I'm going to finish this and then I'll explain it a little more, okay? All right, so then back to the problem set. Whoops. Okay, so then here, if we're looking at B, so does everybody understand A?
Yes.
Okay, so everybody sees what I did there? So bottom line, if you're multiplying, your decimal, which is at the end of a whole number, is going to move to the right once, and it's going to get filled in with a 0. So your answer is 540,000, not 54,000. So then here, okay, you can probably guess what's going to happen. We have a decimal at the end of the whole number, okay? We're dividing, so everything's going to shift to the right one spot, not the left, because we're getting smaller, so we got to go to the right, okay? Which means that the decimal is going to go which way? Left. Left. Okay? Because everything's moving over, like here's the decimal, everything's moving over the decimal one spot. Okay? So that means we're losing a 0, basically. Okay? So now we have 5,400 instead of 54,000. So it's getting smaller. Okay? Henry?
You want us to put the decimal point and then 0 to 10? Yeah.
Sorry, one more time?
You want us to put the decimal there, the decimal point, and then you want us to put the tens like the 0 part?
No, you don't have to. Like, do you mean here and then like that?
Yeah.
No, you do not have to. Because your answer now is just 5,400. So the decimal is optional. You don't need to put it there. Okay, Charlie?
Every time, like, is it also how much zeros it has, like, when you move the decimal?
I'm so sorry. I missed the middle part. What did you say?
When you move the decimal, like, of how many zeros are there? So, like, there's 3 zeros, you move it 3 times. Just one.
Remember, it's the multiple of 10 that you're looking at, not the number. Not the number that you're working with. It's the whatever you're multiplying or dividing by. That's how many times it moves. The 10. 10, 10, 10, 10. Over here, 100, 1,000. That's going to tell you how many times to move, not this number. Okay?
You move it 1,000 times.
No. How many zeros are in 1,000?
3.
So how many times are you going to move it?
3 times.
Okay. All right. Cool. So now here's what I want you to write in your notebook, and then I will turn you loose to finish the problem set. Okay. So in your notebook, I want you to rewrite it on today's lesson page. Okay. So lesson 2, this is what you're writing. Okay. Multiplying. We move left. Okay. Decimal moves right. Okay? So you could even say like the number moves left. This all looks like a bunch of jargon, I know. But when we're multiplying, your number moves left on the place value chart, right? Number moves left when we're multiplying. Decimal moves right. Does everybody understand what's going on there?
Yeah.
Okay, so you're rewriting this, like you're writing this on lesson 2 in your notebook. So the lesson paper you started today, this is what you're writing.
Can you already wrote something besides that?
Yeah, of course. You can write as much as you want, as long as it's related to math. but related to the lesson. And then maybe draw a line or something and say when you're dividing, the number moves right and the decimal, which is that little dot, right? The decimal moves left. Okay, everybody understand what I'm getting at there?
Mm-hmm.
Okay, Donnie?
For a, like, instead of writing the word decimal, can you put like a symbol as a 0.0? Like a little dot?
Sure. But you got to know what that dot is, though. So your notes are for you. Okay, so I'm not going to be too picky about that, but I do want you to have this down. Okay? All right. And so, one last thing I want you to write there, okay? When you're multiplying, does your number get bigger or smaller? Bigger. Thank you for saying bigger. So you're going to write bigger. When you're dividing, does your number get bigger or smaller? Smaller. So write smaller. If you want to do it another color, that would be cool. You don't have to. You can highlight it too. Okay, so your notes are for you. However you're going to use them, that is for you. But I definitely want you to have this in there because this is like your cheat sheet for the homework, okay? This is your cheat sheet. If you see multiplication, your number's going to move left on the place value chart and your decimal's going to move right. If you're dividing, your number's going to move right and your decimal's going to move left. Charlie.
So the decimal would get smaller?
Decimal does not. The number gets smaller. The number that you're working with. So that problem I did, it was 54,000, what we started with. Then when we multiplied, it got bigger to 540,000, not 54,000. It got bigger, right? So that because we were multiplying. But the decimal is just a dot. It's not. It's a symbol. It's just not a number. It doesn't get bigger or smaller. Okay. Make sense? Sort of. Okay. Yes. Hold on, I'm not there. I will help you, but I'm not there yet, okay? Everybody got this down?
Yep. No.
Almost? Almost?
Do
Okay.
we have to have the smaller ones for the decimal for like the bottom?
Like right bigger, smaller?
No, like the bottom.
I want you to have both parts. If you have both parts, you're good. Okay, if you're good, you may move on to the problem set. Try it out, okay? And I will help you if you need it.
Okay.
Good question. So I would, what's helpful for me is I would rewrite number 13. So go ahead and rewrite 13. And where's the decimal? Yes, yeah. So on the one you rewrote, decimal behind it. And then, since you're dividing, your number's going to move to the right, which means your decimal's going to move which way? Good. How many times? Yeah, so go ahead now.
Did
Just
you know
physically
that,
move
Luke,
the
since you
decimal.
are the math
One,
expert?
two,
Yeah.
yeah. Good, and then you're going to fill in the rest with zeros. So your decimal's here, and then it's 0, 0, 1.
That's so true.
So I like to rewrite it because that helps me a lot. Okay, and I'll come to you in just a second. Okay?
Root is
It's not, it's off.
130 or is it 13? Just yeah. Is it 13.0 or is it?
Sure, yeah, that's fine. I do, it's not helpful, but I do eventually want to use a little bit.
Give me.
You can use your like pencil or cord. Yes. All right, we've got about 1 more minute, friends, and then we're gonna head to